This is the underside of a strip loin primal. So if you imagine like a New York strip steak, there's about, let's say, 12-ish of them if you were to cut this up. We, in this particular application, need to segment out the regions and then need to do more analysis on each region to see how well it's been trimmed. Is it to a certain specification? Does it need to be rejected?
All right. Hello, everybody. Today's session is Vision AI in food production. We're joined by a guest, FloVision, and we're going to be chatting about how to reduce waste and improve efficiency in food processing. My name is Patrick Descher. I'm from Roboflow, and I am happily joined today by Rian McDonnell, who is the founder and CEO of FloVision Solutions. Thank you very much for joining us. Would you like to say hi to everybody, Rian?
Yeah, no worries. Hi, how's it going? Rian, originally from Ireland, so the accent will come out every now and again, but I'll try and speak slow.
Let's kind of jump into today's topic. So when it comes to FloVision, for people who aren't familiar with what you guys are doing, Rian, could you tell me what you guys do and explain some of these photos for me?
Yeah, absolutely. So, FloVision is a food analytics company optimizing the food chain, starting with protein. So, really, everything we do is either related to beef, pork, or poultry today, and we're trying to just make those systems more efficient. So, we work with processors to increase their yield, reduce their waste, put automated QA processes in place, and also increase staff skills. So yeah, the plethora of images are just a lot of different examples and bits and pieces that we've either been doing or are doing. So we do a lot of segmentation tasks, a lot of dimensioning, defect measuring, portion sizing, everything and anything in that space.
All right, now let's take a look at, you sent me a video from something that is this AI guided pork splitting process. And here I see we're in like a kind of industrial meat processing plant. And I see some meat, somebody pushing it through a buzzsaw looking thing. Sorry, I don't know the right terminology for this, but could you tell me, what's going on in this video?
Yeah, absolutely. So, a lot of what we do is somewhat passive, but this is an example of an active solution. So we have a product called FloVision Pro, and effectively, you can use if you've got real time compute on the edge, etc. You can use a lot of real time guidance for people. So this is one where we're showing a laser line assisting a human to hit their marks, hit a customer spec, and be very precise with a cut with this saw. And these sorts of precision tasks, they really add up throughout the day in a food production facility, like a lot of other, high throughput industries where, a couple of millimeters, an eighth of an inch, if you repeatedly improve that and do that every single time throughout the day, it can really, really add up. So yeah, it's a pretty impactful application of our tech.
Tell me more about lasers and AI. I saw these two keywords and I was thinking, is this the end of the world? Lasers and AI.
Yeah, exactly. It's not in violation of the Geneva Convention or anything like that. Um, yeah, so the FloVision Pro application is a lot of laser guidance. So basically, a lot of what we do is, if you're measuring something, say a piece of meat, and you're going to calculate, oh, the human should be trimming here or should be cutting here. We then, in some applications, use that data to show the human that guidance. So show them a line, show them a curve, show them a heat map, whatever it might be for the specific application to act on.
Well, something I like about that is I've encountered other situations where, especially in manufacturing, there are processes where you need to say, measure a certain number of, bubbles inside a piece of drywall when you're producing it. And if you have a dozen production facilities, you'll have a dozen different people making judgment calls about the proper number of bubbles in the drywall. And something nice about having computer vision is you can have the model help count the number of bubbles and return a more kind of subjective, or I should say objective result so that you remove the kind of judgment call. Do you have experience with that? Is that what we're talking about
Yeah,
here?
100%. A lot of what we hit with our customers is objective versus subjective, regularly in these high throughput manufacturing type processes. A human, you're subjective, one person might say one thing, one might say another, but also then they might be only getting a chance to see an anecdotal amount of information. They might be, whenever they're at that position in the facility, they might see 0.01% of the day's throughput, and they're judging their decisions based on that. So a computer vision type solution, obviously, you can get up to 100%, and that can be a lot more informative.
Nice. Yeah, okay, cool, yeah, I like that a lot. That's another facet that I hadn't thought about before. All right. So now that we were talking a little bit about kind of the background and what FloVision is doing in food production, I wanted to explore, your experience, your journey with computer vision. When it comes to going from concept to prototype to production, there's of course a lot of things that we could be talking about, and we'll touch on some of these later. But my first question for you is, at what point did you know that computer vision would play a significant role in your food production, tools and solutions?
Yeah, for sure. Great question. Yeah. So for us, a lot of our initial founding as a company was all about how do we get the right data to the right person at the right time to make those right decisions. We very quickly realized that computer vision, AI, ML was going to be key to that. Because the existing infrastructure is, human walks up, human sees something, human makes decision in real time. Um, so I mean, for us, food is squidgy. Food is it's a biological product. So every single piece is in some way unique. One of my favorite facts is that cattle actually have more genetic diversity than humans. So if you take two cattle from across the world, they'll be more diverse than two humans. So that means that the products we're dealing with are very diverse. So when you're looking at that, you really want to develop particularly modern AI ML type computer vision solutions to try and adapt to that. So that's been pretty key for us in the last couple of years of much more compute, much more larger models, etc.
I can imagine you're definitely tangling with something that I've seen other people tangle with, which is, um, there's a lot of models, there's a lot of work on recognizing humans and, like, kinda everyday objects that we interact with. We can differentiate different human faces from others, but it's very difficult to do that with less common objects or even just animals, right?
For sure, and like it makes sense that a lot of the initial R&D or the last 10, 20, 30 years is in human face recognition and so on, like the completely low hanging fruit. We're in a what I would classify it as a less sexy business. It's a very niche. It's a very not a lot of people want to jump into food production and staring at meat all day. But that also means there's tons of opportunities to take leaps and bounds.
Cool. Well, this is actually a good kind of pivot point to the next topic that I wanted to talk about, and to kind of get everybody into the same headspace as me, at least. When it comes to vision models, I tend to have two buckets that I categorize things into. And, one of them is I tend to think that there are kind of pre-trained models out there, general purpose models. These might be, really large vision language models. Some of the stuff we're talking about that's been developed recently to, recognize human faces. These are really good for solving kind of general challenges, but they might require some like more computing resources, or you just might not be able to run them in your environment depending on the settings. And then the other bucket that I like to think about is like task specific AI models, or sometimes I call them like purpose built models. And so my question for you is, there's actually kind of two questions here, and you've already answered the first one, but could you tell me about, some of the things that you are trying to detect? And then what's your experience been? Did you ever try using any pre-trained AI models to recognize those things? Or are you only using sort of like custom purpose-built AI models?
Yeah, for sure. Yeah. So from our perspective, yeah, as vaguely touched on earlier, it's a very specific data problem that we have. There's not that much training data out there. We collect our own data and we use our own data, and that's just the way it is for us. We're very, very niche in that way. Um, we do only recently, in particular, with the multimodal LLM type world, we played around with a few of them as to can they automate some early stages of data collection and data filtering to speed up the development of our own specific, task based models, if you like. So it's sometimes a bit of both. You can try and play with that. But yeah, generally we're working towards getting a very narrow model that can scale into the hundreds of thousands or millions of pieces that it can be measuring. So it's got to be quite robust.
Nice. Yeah. Man, I have a lot of questions to follow up on that with. Before I go down some of those rabbit holes though, I was thinking this image that you sent over would be a good place for us to kind of talk a little bit about computer vision development. I see here there's a piece of meat, and it looks like there's some visualizations that may have come from a computer vision model. Just to get started, could you tell me what we're looking at here?
Yeah, for sure. This is the underside of a strip loin primal. So if you imagine like a New York strip steak, there's about, let's say, 12-ish of them if you were to cut this up. A lot of our work, particularly in the beef space, is working with these. They're called primals. Um, when you look at the segmentation work that's been done here, you can kind of equate it to a lot of like geography and geographical features. Like you got like hills, mountains, depths, ridges, all to define these regions. So a lot of the times when we're annotating, we're thinking of a kind of like map making to a certain extent. But yeah, we in this particular application, need to segment out the regions and then need to do more analysis on each region to see how well it's been trimmed. Is it to a certain specification? Does it need to be rejected, upgraded, downgraded, etc.?
Nice. Okay. Um, this is sorry, I'm gonna go like right into some kind of technical stuff, but for this kind of use case, so you mentioned this is segmentation, right?
Yeah. Yeah.
Um, there's like object detection, segmentation. There's these kind of different vision models that people can train, and I I think I encounter less segmentation kind of challenges than object detection. So, could you tell me a little bit about why the segmentation is necessary in this case?
Yeah, we do a lot of segmentation. Just the applications that we tend to end up doing because object detection serves a great purpose. It's much more lightweight, etc. But a lot of the time, we want to be more precise on like the boundaries of our areas and so on. Where object detection is going to give you a box. Is there going to be bits and pieces hanging out? Is that going to make the box really big? And then you're approaching a different object to the left or to the right or something. So segmentation gives us a lot more robustness to a lot more edge cases, etc. And sometimes we actually need to dimension things, which we can do much more easy off the back of a segmentation task.
Nice. I guess segmentation is also the key to measuring the proportion of peas on a plate. Is that right?
Yeah, yeah. I mean, so some of the applications we do, we use 3D cameras like point clouds, and we're using that segmentation mask. And then you can see how you could match that segmentation in a 2D space into a 3D space and get a volumetric analysis, etc.
Cool. All right. Now the other thing that this image makes me think about is I often hear people say something like general rule is if you can train a human to recognize something, you can also train a vision AI model to recognize it. I was looking at this and I was like, well, off the bat, I probably couldn't recognize the jump region, the wing region, the blade meat. But yeah, perhaps I could be trained to do this. I don't know how difficult it would be to train me to do that and how much time I would need to study this stuff. Could you tell me a little bit about yeah, what was the process for training a vision model, developing a vision model that could help identify these different regions of a crosscut of meat like this?
Yeah, yeah. Give me a week and I'll have you chugging through some images if you want an annotation task.
Me versus
Yeah,
the
so
AI.
it's there's in particularly in protein is an industry that has a ton of tribal knowledge. Most of the stuff is in people's heads, and a lot of our real value is we can connect the protein knowledge, like looking at this image, being able to tell what is what and where it is, with the technology knowledge, the AI, the building the model. So, that's sort of the intersection of that Venn diagram, protein knowledge and tech knowledge, is like kind of where we sit, and there's not that many people that sit in the middle of that Venn diagram. So that's really a lot of our secret sauce is being able to put all that together. And then it's just all about, documentation and training people to annotate and, being doing all the boring stuff well. QA that, feedback that, etc. Get someone to the place where the supervised learning ticks over and ticks over, and then eventually you get some pretty powerful models out of it. That's our bread and butter to a certain extent. Excuse the food pun.
No, please, more puns. I've been failing to deliver any puns in this talk so far. So you're picking up the slack. So my next question about that is, I like you were talking about, teaching people how to also teach the AI, labeling images, things like that. I often think about, yeah, a question of how to be successful with Vision AI. I've definitely played around every now and then where I'm like, I have an idea. I think maybe Vision AI can do that. And then I train a first model, and then I'm like, oh, I did it wrong. Okay, that's not working. Okay, I'm gonna have to start over. Do you have any sort of, I don't know, stories, or do you have any experience about, how do you ensure you're successful when trying to make vision AI models that are like this, capable of recognizing different regions?
Yeah, I mean, to be honest, it's they're going to be pretty boring answers, but it's mostly around iteration speed, fail fast, etc., etc. But yeah, when we work on these types of complex problems, some of them are more complicated than others, first of all. But it's all about quick iteration, getting good feedback. Like for us, we'll talk to the customer, make sure we understand exactly what they want. Some things can get lost in translation when this problem may have never been written down before in the history of the company. Just like it's just been transferred from person to person verbally. Um, but then you get through the edge cases, and then you're flying. So it's all. I know when we start training a model in Roboflow, it's always like, oh, get 100 images or get 50 images, and that's usually actually trust that is what I'd say. Do 100 images and start training the model and see how terrible it is. But there might be a grain of truth in there somewhere. But even when the model doesn't give the output you want, it's going to be a learning moment. It's going to be, okay, can I simplify this problem? What does a true MVP look like here? What is the minimum of that? What can I remove in terms of complexity?
Cool, nice. On that topic, I was also hoping to ask you, like, 'cause this is obviously a very specialized, task that we're looking at here, and this is definitely, like I was talking about, like, purpose-built, specialized AI model. Um,
Yeah.
Previously, I was one time doing some research about just, like, thousands of different kinda models that were trained using Roboflow, and I was looking at a 6-month period, and I had all these different data sets that I was looking at, like, anonymously, and they were all data sets that were in production somewhere. Out of all of these data sets I was looking at, one of them was the largest, was something like 40,000 images in the data set. Um, the smallest one was like 109 images. When you're making models like this, can you give me any kind of like ballpark estimates of, to get into, because you mentioned kind of testing. Yeah, you can start testing with 100 images.
Yeah.
How many images do you guys usually get to label to kind of get an accurate model, and what's your experience there?
Yeah, for sure. So it varies depending on the problem complexity, obviously. But Speaking particularly for segmentation, segmentation needs a good corpus of data to start getting the boundaries quite accurate. With a detection model, you might be able to spin something up quicker, and also the annotation time is quicker, so you can race through 1,000 images in a day or something with detection. But usually, what we see is you're talking in the hundreds to get something that is narrowly MVP. So like might do one station, one environment. But then, if you're trying to generalize that across different environments, different backgrounds, different lighting, etc., then you can quite quickly get into the thousands. But you really, I think, data diversity is your friend. Like we have different environments now that when we first installed some of our applications, we were locked into. For example, this is on a blue background. Now we have different stations on white backgrounds, and you can have stainless steel backgrounds as well. And that you can see when you first go to them a sizable accuracy drop. But if you had some of them, even 10, 20 images on a stainless steel background from the start, it would make a world of difference to that jump. So yeah, data diversity is really the friend there.
Nice, cool. Sorry, one last question about this on kind of model development. We train a model a lot of times in something like Roboflow. You'll see some kind of automated kind of benchmark or something where we'll tell you, okay, according to this data set, we think that, and when we compare it to the ground truth, stuff like that, okay, you're 90% accurate, 95% accurate. Every now and then I kind of wonder about like, is that always helpful to people? Like, sometimes we might chase after accuracy numbers that we don't really need. I've seen situations where even in production, gigantic corporation, yeah, they're happy with a 81% accurate model because, they're measuring the trend of something over time, and if it's 80% accurate and it's always the same accuracy, at least the trend is always the same, right? So I wanted to ask, like, what does accuracy mean to you? Is it like, do you really need to go after that 100%, 99% accurate, or are there some times where it's like, okay, 70% is good enough for this because before it was 0%, so 70% is actually a 70% gain?
Yeah, absolutely. It's a great question. Yeah. So from our perspective, if we get something wrong, no one dies. That's the main thing that we keep telling ourselves. So if you're dealing in healthcare, you got to be bloody accurate. But for us, it is, as you said, getting a trend. Now the trend has to be meaningful. You got to remove noise from it, and you can do a lot of clever techniques based on confidence thresholding and so on to filter out data that you might be unsure of, etc. So you know, uh, a lot of the time it depends on the customer's need. We always try and get a sense of really what is an MVP in terms of accuracy. Where does that threshold sit? What quantity of data is one question. Is it 100% coverage? Is 80% coverage? You're filtering out your bottom 20% in terms of confidence. So that's one question. And then within that 80% that you're returning, what accuracy does that need to be? So, we try and tweak both of those to make sure we're giving the customer what they want. Um, and yeah, for us, if you get into the 90s, you're doing great. You don't have to be 99. That's very difficult to get, and a human could never do it because it's too subjective and too diverse. So if you're beating a human, you're in the 90s in our industry. Um, so yeah, for us, those tend to be the key things. I will say we, depending on the model, we'll look at what the customer cares about for that particular feature, and then we'll decide, well, what metric do we want to use to define what does accuracy mean for this. So, for some models, false positives might be much more impactful in terms of accuracy than false negatives. They might matter more to the customer. So a lot of the time we'll take like the confusion matrix or something, and we'll weight things accordingly in our own side, of like, to get our own like score for each model, if you like.
Nice, cool. And sorry, I remembered earlier you mentioned you were beginning to look at how to create kind of multi model, not multimodal, but like a process that includes multiple models, like maybe like a larger model and then a purpose-built model. Kinda how far along are you in that? Because I always think that's a very interesting, technique that can allow you to get, like, much better accuracy than before or save time.
Yeah, for sure. It's much more of like right now today we use it for a lot of proof of concept work rather than production work of like, okay, can we get to an initial POC for feature X, Y, or Z? And then 100 images in, 150 images in, and by then, you might be using the auto labeler or something within Roboflow. I will say the SAM and SAM2, smart labeling and so on. That's an unbelievable unlock in terms of human efficiency for annotating and getting models ramped up. But there's a lot of other um, tweaks and quirks that we try even outside RoboFlow workflow. But having that sort of stuff just easy plug and play is pretty key for us. And Patrick did not expect me to say that. That was all on me. Sorry.
I was about to say, we have this very nice, SAM2 labeler available in RoboFlow if you're curious to try out what Rian just mentioned. Very cool. Yeah. All right, then let's move on. I see some people are also talking about this in the comments. All right, so we spent a lot of time there talking about how to develop vision models, and I wanted to explore a little bit on the side about deployments. After you have a vision model, we have to run it somewhere. In my, time doing webinars and interacting with people online, I see a lot of questions that are kinda like this one that I put on the screen where they'll say something like, "I have a water bottling plant, and we operate at 2,400 bottles per minute. Um, Hey, I just saw this demo of something. Is that gonna work for me?" And, that's a really huge question with a lot of variables, so I don't think on any webinar we can really say, here's the end all be all answer for a question like that. But I did want to spend some time talking about, running AI and kind of either at the edge or at the cloud. And, in food production, I'm sure you encounter this question quite a bit. So, Rian, how do you kind of navigate this question of where to run AI?
Yeah, for sure. And I will say, going back to the previous question, like, of course, it depends, but it also doesn't just depend. Now, today, it's becoming maybe AI isn't the limiting factor. Maybe the camera is the limiting factor. It's not necessarily that the model is the limiting factor. It could be it's gotten to the stage where it doesn't need to be the limiting factor necessarily today for those applications, which is incredible to see. Um, yeah, and I mean, from our perspective, we think about this a lot today. In the cloud is obviously very easy to spin up, very MVP. It tends to be what we start with, um, but we are starting to play around with more and more edge of how much can we get on the edge, in terms of one cutting down our cloud cost, two being faster and more real time. But then three, the con is managing accuracy with smaller models. So some things that we're very keen to continue to play around with is can you run something on the edge and based on a confidence rerun it on the cloud if you feel the need to or whatever it might be. So that's a lot of the stuff that we're progressing towards here.
Nice. Yeah, very classic. The classic trade-off of latency and accuracy. I've been thinking a lot about that this week. We're coming up with some new models, and we're trying our best to give people very fast and very accurate models that they could run at the cloud. Sorry, at the edge. Could you tell me a little bit about kind of, yeah, at the edge, if you see a food environment and they say, yeah, well, we don't have internet connection for security reasons. Yeah, do you have any sort of questions or considerations that viewers might be able to bring with them when they're starting to plan and think about, okay, yeah, I want to use Vision AI and I want it to be in a situation where maybe I don't have internet connection. What are some of the things that you start to think about when you're in that situation?
Yeah, it's a good question. Right now, we just beg them to have internet connection, because even if you're running on the edge, we would still want to know what was happening. You know what I mean? Like get metrics off the device and uptime, etc. So I think in our industry and in our position, we'd be just begging for them to run a Ethernet cord down somewhere. And for us, we've always been able to get that done. But yeah, I mean, at the edge, headless to some extent, where you can't actually see what's happening in real time yourself, can be a little bit scary from those perspectives. If you're working with a new customer or so on, you don't actually know how well you're performing for them on any given day. You're sort of you're blind to that. So we are always default cloud, default nice and easy. Like, let's not overcomplicate things. We'll worry about at the edge later, after we're settled, after the customer trusts us, after we're producing good results. And then it's like, okay, can we match that at the edge at a later date? So that's how we approach it.
Cool, nice. Well, and I love that you mention, having insights into what is happening. I think that that is, no matter where the inference is happening, if it's happening on an edge device or on a cloud device, I think for a lot of organizations, it's super helpful if you can consolidate records, detections from, multiple lines, multiple locations into a centralized, dashboard or repository somewhere so that you can, understand the full situation of what's going on. Okay, but with that said, I did want to talk about running Vision AI in the cloud a little bit. I was curious, what was it on your website? I saw something about like millions of pounds of food protein evaluated. Could you tell me a little bit about the scale at which you guys are operating?
Yeah, for sure. I was actually just went to the website to see what the number was now.
Maybe it
Twen-
must get updated.
23 Yeah, 23 million kilos. So I'm a metric boy, so I still work in that
I'm sorry.
from my European heritage. So multiply that by 2.2, roughly 50 million pounds. Um, but yeah, I mean, in terms of scale today, today we will process over 500,000 chickens and many thousands of beef objects into the 10,000s pretty soon here. So that's all running through either cloud or edge, and that's a ton of data to manage and a ton of insights to be pulled from for our customers. So that's a challenge in itself, dealing with all that data.
For, at that scale, when you are, if I'm a viewer or if I'm somebody that's getting started in Vision AI and I'm thinking about, cloud infrastructure, there's a lot of options on the market. What are your sort of recommendations? Like, what do you look at when you're shopping for cloud infrastructure and kind of what's that experience? Do you have anything that you can share with people?
Yeah, for sure. I mean, toot first of all, we have, been pretty embedded with a lot of Roboflow tools for the last couple of years. We initially started with just the annotation and that so on. But, we've grown into using a lot of cloud services, etc. And to be honest, when you're dealing with the scale that we're dealing with, a lot of it comes down to, reliability, uptime, etc., and cost and how you trade those off. So when we were comparing AWS, GCP, all the good old classics, to Roboflow, what we saw was Roboflow actually could get a bulk discount that was actually cheaper than AWS for us, because whatever we're bulking into everything else, and it's less headaches on our side as well. So yeah, that you don't really want to be woken up at 3 in the morning having to deal with an outage. That's what you're trying to avoid a lot of the time.
Nice, cool. Yeah, there's definitely something to be said for like an all-in-one experience of, you develop something somewhere, you create some automations with it, and then you run it all in the same platform. There's simplicity can definitely result in less
For sure. For
surprises.
sure.
Yeah.
Yeah, and our objective is always how can we get as many of our the bread and butter models I sort of referred to earlier, like let's keep them simple. And then, there are some things that are more niche and tweaked and strange that then we have to spin up our own bits and pieces, but keep everything as simple as possible and as little overhead as possible.
Previously you and I had a conversation. It feels like a million years ago, but it was actually probably around Earth Day. And back then I had a lot of thoughts in my brain about AI impact on the environment. Are there places where we see AI can actually have can AI have a positive impact on the environment? And I noticed you guys because you have this mission statement that talks about making food production more financially sustainable, but also environmentally sustainable at the same time. Can you tell me a little bit about that mission, how you arrived at that, kind of what you've seen recently in terms of pursuing that goal?
Yeah, absolutely. So I mean, the way I look at it is, food isn't going away. When you look at the climate problem, you look at fossil fuels, okay, great, there's alternatives. You look at all this, but food is food. We need food. Food is not going to disappear or go to zero. So the solution for food is how do we make that process as efficient as we physically can. Um, and looking at that, that ties pretty well with yield benefits. So you can actually be more efficient, reduce food waste, and therefore actually also increase profit margins. So the capitalist model lines up very well with the sustainability model there, which I'm all for. So that's really where we see ourselves and where we've been pushing forward is how do we align financial incentives and environmental incentives there. Um, and whenever you get to saving a couple of grams here and there, when someone's going to do that 100,000 times, a million times, 10 million times a year, it really starts to multiply. So high throughput industry, high carbon intensity industry, meats we all know are pretty significant there. So yeah, every little helps.
Cool. All right. Now, before I let you go, is there kind of like anything else that you got going on that you want to share with us?
We're hiring, first of all. Please, anyone, ML engineers, software engineers, please feel free to reach out. I'll throw my email in the chat. Um, and yeah, no, I mean, I appreciate you having us. Happy to share. I think Roboflow is a fantastic platform. Does great things, makes things nice and easy, and yeah, hopefully more upgrades to come soon.
Wow. Okay. Well, thank you very much for saying that. And thank you so much for joining us today for this chat. I really learned a lot of new things. And so that's where our presentation will conclude today. If you're watching this, say, on YouTube later on, and you want to join the live session like this, please go to roboflow.com/webinar. Thank you very much.